Let's take a look at this problem. We got x squared plus 2x plus 9 equal to 0. And I want to solve this using quadratic formula. Well, quadratic formula says you have to have 0 on one side, so that's good. And it has to be quadratic, of course. So let's identify a, b, and c. A is the numbers in front of our x squared, which is 1. Remember, the invisible 1's there if there is no number. B is numbers in front of our x, which is 2. And c is our number at the end, which is 9. Now our quadratic formula is x equals negative b plus or minus square root b squared minus 4ac all over 2a. I always tell people if they're learning it for the first time or just not very good at the quadratic formula that it's beneficial to put parentheses in for your variables before you start plugging numbers in. So everywhere I have a variable, I'll put in a set of parentheses. Now everything else is going to remain exactly the same. Now where this is really beneficial is where you got a bunch of negatives involved. It doesn't help as much in this problem where everything's positive. But again, everything remains the same. I just replaced the variables with sets of parentheses. We said a was 1, so everywhere I have an a in my formula, I'll put in a 1. We said b is 2, so everywhere I have a b, I'll put in 2. And we said c is 9, so everywhere I have a c, I'll put in a 9. So we got negative 2 plus or minus square root 2 squared is 4 minus 4 times 1 is 4 times 9 is 36. So 4 minus 36 all over 2. Which gives us negative 2 plus or minus 4 minus 36 is negative 32 over 2. So that gives us negative 2 plus or minus 32. That's negative 1 times 2, 4, 8, 16, 32. 5 2's. Now that's prime factorization. You could have did 16 times 2 also. If you're wondering how I got that, ignoring the negative, that's where the negative 1 comes from. We look at 32. 2 times 16 gives us 32. 2's prime size circlet. 16 is 2 times 8. 2's prime size circlet. 8 is 2 times 4. 2's prime size circlet. And 4 is 2 times 2. And these 2's are prime, so I circle those 5 2's. The negative 1's going to come out as an I. And we're looking for pairs of something. Here's a pair of 2's, so they're going to come out. And here's a pair of 2's, they're going to come out. So we got negative 2 plus or minus. This pair of 2's came out as a single 2. This pair of 2's came out as a single 2. And this negative 1 comes as an I. And we're left with a single 2 inside. All over 2. Which gives us negative 2 plus or minus 2 times 2 is 4i. Square root of 2 over 2. Now, since we have an I, we want to split this into two separate pieces. So this would be negative 2 over 2 plus or minus 4 square root of 2 over 2i. So you want the real part separate from the imaginary. So I took this negative 2, put it over the denominator, and I took the 4i square root of 2 and put it over the denominator. Negative 2 divided by 2 is negative 1. Plus or minus 4 divided by 2 is 2, so we got 2 square root of 2i. Now you can put the I in the back like this, or if you want to put 2i square root of 2, I'm fine with that also. It's however you want to write it. Technically this is the standard form, but this actually avoids confusion if you write it this way. Sometimes people get confused whether I is out back here or it's under the square root. It's never under the square root for this class.